let's review the main ways that we classify the elements into different types of groups. Here is a periodic table. It's got all of the elements on it. You've even got the rare earths down here. The first thing we should notice is the columns are called groups or families, and they denote selections of elements that all share certain physical and chemical properties that differentiate them from the other columns in the periodic table. The rows of the periodic table are called periods, and they show off the cyclic nature of these groupings of properties coming up. There's three major ways that we tend to divide the elements into different groups. And the first one is based on the main group elements versus the transition metals. The main group elements are simply all of the elements that are in groups 1 and 2 and 13 through 18. These are the most abundant elements in the solar system and the most of the abundant elements on Earth. This is in contrast to the transition metals. These are the classic metallic elements, and these were discovered first, which is mainly why they get their own group. Transition metals excludes the lanthanides and the actinides, and these are all lumped together because their special electronic configuration gives them subtle and complex chemistries that have been fun to play with. So that's the main group elements versus transition metals. Those are simply by what groups the elements are in. The next way we divide up all the elements is metals versus metalloids versus nonmetals. The metals covers all of the metallic elements. That includes most of these first 13 groups, as well as a handful of the heavier elements in groups 14, 15, and 16, and it includes the lanthanides and the actinides. Now, these are called metals because they all share certain properties. They are lustrous and ductile and malleable. They also tend to be good conductors of electricity and heat. All of these elements tend to form ionic compounds. Compare this to the nonmetals, which are the lighter elements and the elements that tend to make up groups 18 and 17. These have the opposite properties to metals. They tend to be brittle, or they tend to be liquids or gases. They are non-conductive, and these are the elements that can form both ionic and covalent compounds, and a discussion of that is coming up in Chapter 4. But what about the ones that are neither one nor the other? These are the semi-metals or metalloids. They tend to behave physically like metals in that they have some malleability, some electrical and thermal conductivity, but chemically they tend to behave more like nonmetals. These elements have some ability to form covalent bonds, which is very rare in the metals. So that's the second way we differentiate groups of elements: metals versus nonmetals versus metalloids. Lastly, there are a couple groups that I would like to call your attention to. First, we have the alkali metals here in group 1. They tend to form +1 ions, and they are very, very reactive. Next are the alkaline earths. These tend to form ions with a 2+ charge, and they are less reactive than the alkali metals. Over here in group 17, you have the halogens. That means salt former. And these all tend to form -1 ions. A cool fact about the halogens: as you go down this group, you go from gases like fluorine and chlorine to a liquid, bromine, to solids like iodine and astatine. Lastly, you have the noble metals hanging out in group 18 over here. These are known for being chemically inert and generally stable. They do not like to react and form compounds. All of the other elements in the table try to gain or lose electrons so that they have the same electron configuration as the noble gases. That's the whole reason why chemical reactions occur. I hope that this covered the major divisions, you should just have a general idea of what elements fit in where. And I will see you guys on Friday.